Hello guys, welcome to my channel Quality Inspection. Today we are going to see the topic post-weld heat treatment. If anyone new to my channel, please subscribe my channel. If this video are really interesting or admired, so just put the like button. Let's we go into the topic. What is post-weld heat treatment? During the welding, due to sudden heating and cooling, the stress will be formed in the welded area. To uh, reduce the stress, we are doing Pwht, post-weld heat treatment. If the residual stress is formed inside the weld, the strength of the material will get reduced. To enhance the strength, we are using this post-weld heat treatment method to improve the strength of the weld. So this post-weld heat treatment is the one of the controlled heat treatment process which we are reheating the welded area, particularly up to 50 mm from weld in each side. We are reheating. The temperature which we are using for reheating is below the lower critical temperature. That lower critical temperature is 7 to 7 degrees Celsius. We are going to heat the welded area below the lower critical temperature in a controlled method. Once it's attained the required temperature, we have to hold for the particular time. Then only this heat will transfer distributed equally throughout the area. The another thing why we are doing Pwht, due to sudden heating and cooling, the hydrogen which is formed during welding, it will be stuck inside the weld. Because the formation of hydrogen inside the weld, it will take some time to come outside from the weld. So if the welded area is cooled very fastly, it will be stuck inside. So there will be a formation of hydrogen disc crack. To avoid that one, after welding we are doing Pwht. If you are doing the Pwht, the hydrogen which is entrapped inside the welded area, it is possible to come outside from the weld. That is also a benefit. Then another thing, due to sudden cooling during the welding, there will be the formation of brittle microstructure. To improve the metallurgical structure, we are doing Pwht. When we are doing the Pwht in a controlled manner, in controlled method, the structure, microstructure will be changed from brittle microstructure to ductile structure, which is ferrite or perlite. Then what are the benefits if you doing Pwht? If you are doing the Pwht, we can improve the ductility of the material, and also we can reduce the stresses which is formed during welding. The another thing, we can reduce the risk of brittle fracture. And another thing, uh, the hydrogen which is entrapped inside the well, we can remove it, so we can prevent the well from hydrogen induced crack. and we can improve the microstructure, that metallurgical structure. We can change the metallurgical structure by using this pwht. When we have to do the pwht, first of all, based on the service condition, if the welded area, that welded things is using in caustic service, so we have to do pwht. Then another thing, based on the material grade and thickness, if you want to see the uh, holding time and soaking temperature, you can see from code of constraint like ASME section 8, you can refer it, and ASME B 31.3 also you can refer it. From there you can get all the details regarding the holding time and holding temperature. Then another thing, if you want to reduce the hardness, if you require some specified hardness, you can use this pwht. Actually, for the stainless steel and CRA alloys, they are not doing pwht. Why we are not doing pwht on the corrosion resistance alloys? If you are heating the SS stainless steel welded area between 550 to 630 degrees Celsius, the chromium oxide layer which is formed at the surface will be break and carbon will add into the chromium, so chromium carbide formation will be there. So if the chromium carbide formation is there, the metal can easily get corroded, and it will be formation of sensitization. Then for CRA alloy like nickel alloys, if you are doing pwht, it will reduce the corrosion resistance. So if you are doing a pwht, corrosion rate will be increased. So to avoid that only, we are not doing pwht. There are so many methods to do the pwht. First one is fixed furnace method, the second one is temporary furnace, and third one internal firing, and fourth one local heating, fifth one partial heat treatment. The fixed furnace, in fixed furnace method, the furnace will be very large and is very expensive to operate. We can do the heating by using gas fired or oil fired or electrical resistance heating element. It will be like the process of heat treatment. You can see this furnace. The furnace will be fixed. We are placing the component which we are going to do pwht. So there will be a temperature recorder. It will record the temperature. If you want to increase or decrease, everything we can control by using the temperature recorder. Then another one, temporary furnace. Actually, for the pressure vessel, we cannot load or unload the pressure vessel in fixed furnace. To avoid that loading and unloading, we are constructing the furnace wall around the pressure vessel. There will be a gap between pressure vessel and furnace wall. The burner, the gas burner is fixed on the furnace wall at each end. So from there heat is transferred to the pressure vessel. The flame which is in the gas burner should not contact with the flame which is in gas burner should not contact should not direct contact with that vessel, so we have to take care of that one. This is a temporary finance. You can see inside which one we need a PWHT we are placing inside, and we are constructing the wall, finance wall, and we will do PWHT. Then internal firing based on that word internal, we can know we are doing heating internally of the vessel. If you want to do PWHT, there will be like a nozzle or man ways like manholes. So we are inserting the burner burner inside the nozzle or man ways. So we are heating the component which we are going to do PWHT. We are heating by using a control method. There will be a temperature recorder will be there. Based on the temperature recorder, we are monitoring and recording the temperature of the component. You can see this diagram. There will be like a nozzle is there, so from nozzle we are inserting the burner. From burner, the burner that will produce the temperature. That temperature, it is transferred to the all over the component equally. There will be like a holding time will be there, so it will depends upon the thickness. So we have to follow the standard reference for holding time as well as the soaking temperature and holding temperature. So we have to take care of all the things while doing the PWHT. Then another thing, localized heating. This localized heating is suitable method for piping for as well as the circumference weld. So by using this localized heating method, there will be like a ceramic bands. That ceramic bands we are fixing around the circumference of the weld. So this band will produce the heat. So from that band the heat is transferred to the welded area. That band we have to fix around 50 mm from the weld in each side. We have to do this one heating band around the weld. For this localized heating, for to check the temperature, the thermocouple we are inserting, we are attaching the thermocouple on the welded areas from where we have to get the temperature reading. So we are placing the thermocouple. So thermocouple are fixed by using capacitive discharge welding method. Then another thing, before doing the PWHT, what are things we have to see? First of all, we have to check the calibration of the equipment and their conditions. Then other thing, which area we have to do PWHT, and for that what is the heating and cooling rate, and what is the temperature, holding temperature and duration. Everything we have to check and verify before PWHT. Then another thing, up to 300 degree Celsius we can heat very fastly. After that we have to heat very controlled manner, that we should not exceed 200 degrees Celsius per hour. That is the thing. For the holding temperature and holding time, you can refer the necessary codes. You can get the information from that necessary codes. Then after reaching the 300 degrees Celsius while cooling, you can cooling it at normal area, normal process. But up to 300 degrees Celsius, you have to cool in controlled manner. Uh, this one for thermocouple. Thermocouple is like is a instrument which used to detect the temperature of the area which we are doing PWHT. We are fixing the thermocouple um, on the near to that welded area, so it will sense the temperature of the particular area. So based on that only we are adjusting the temperature. Then for the pipe diameter is up to 305 mm or less, we can use one thermocouple, and pipe diameter above 305 mm up to 610 mm, we can use two thermocouple. Pipe diameter above 610 mm, we can use four thermocouple. The thermocouple shall be attached to the component by capacitive discharge welding only, and this thermocouple shall not be in contact with electrical heating elements or subject to flame impingement by gas or oil burners. Thank you. If you like this video, just put your like button, and if you have any doubt, just put a comment, so I will try to answer to that comments. Once again, thank you. We will see in another new videos. Thank you.